Good morning, children. Let us continue our chapter Units and Measurement. In the last class, we discussed about error, isn't it? How to calculate the absolute error, percentage error, and after that we discussed about the error when two physical quantities are added, subtracted, or finding out the product, quotient, and power. So, what will be the error in the resultant? So we have the equations, we derived all these things. Okay, now based on that we have to discuss some problems, then after that we will move to the next session, that is the significant figures. So I'll read the question. You take your textbook and page number 26. The first question which we are going to discuss is example 2.8 in your textbook, example 2.8. So you take your textbook and write down the question in your notebook. And the question I will read now. The temperatures of two bodies measured by a thermometer are T1 is equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius and T2 is equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and error. So that is the question. We have to find out the temperature difference. Okay. So that is temperature difference, you know, it will be T2 minus T1, and we have to find out what is the error in the resultant temperature or the final temperature. What is the error that we have to find out. So here this is the temperature. T1 is 20 degrees Celsius plus or minus 0.5 degrees Celsius and T2 is 50 degrees Celsius plus or minus 0.5 degrees Celsius. So we can relate it with the general expression. What is it? Z is equal to Z plus or minus delta Z, isn't it? Or A equal to A plus or minus delta Z. Sorry, delta A. Isn't it? Delta A. So this is the true value and this is the possible error. Isn't it? This is the absolute error. Mean absolute error. So we got the equation like that. So here we have to find out the difference in temperature. So what is the difference in temperature? T is equal to T2 minus T1. Isn't it? T2 minus T1. So what is it? 50 plus or minus 0.5 minus 20 plus or minus 0.5. So first we can find out what is the difference in the actual value or the true value. That is, what is it? 50 minus 20. Isn't it? 50 minus 20. Then if two quantities we are finding out the difference, the error will be, what is it? Delta Z is equal to delta A plus delta B. Sum of the absolute errors. If you are finding out the sum or difference, then the resultant error will be the sum of the individual errors. Delta A plus delta B. We have the equation. So here what is it? Plus or minus 0.5. Isn't it? Delta A plus delta B. Delta A plus delta B. Isn't it? Delta Z is, yeah, take B is also this. B plus or minus delta B. So A and B. This is our A, this is our B. So delta Z is equal to delta A plus delta B. This is delta A, this is delta B. Okay. So plus. So what is the final result? It is 30 degrees Celsius. Then 50 minus 20 is 30. Plus or minus, how much it is? 0.5 plus 0.5, it is 1 degree Celsius. So the difference in temperature with the error, it is 30 degrees Celsius plus or minus 1 degree Celsius. Okay, that is errors we are adding. Don't subtract these errors. Okay, that is wrong. What is it? The resultant error will be the sum of, isn't it? In both measurement there is an error. So in the resultant, sum of those errors will come. Okay, so that is the question. Okay, so you copy this in your book after writing the question. Write down next question. It is not there in your textbook. You write it. I think it is there in the exercise part. Okay, the exercise part it is there. So write down, it is not there in the textbook. Write down two resistances two resistances. R1 is equal to 100 plus or minus 3 ohm, and R2 is equal to 200 plus or minus 4 ohm. R1 is equal to 100 plus or minus 3 ohm and R2 is equal to 200 plus or minus 4 ohm are connected in series. What is their equivalent resistance? What is the equivalent resistance? That is the question. So how will you do? What is the equivalent resistance when two resistances are connected in series? That is R is equal to R1 plus R2. Isn't it? It is R1 plus R2. So what is it? 100 plus or minus 3 ohm plus 200 plus or minus 4 ohm. Isn't it? So 100 and 200, it is the true value. So it is 300. Then how will be the error? Delta Z is equal to delta A plus delta B. Isn't it? While adding. So what is it? Delta A 3, delta B 4. So it is 7 ohm. So the answer is 300 plus or minus 7 ohm. Okay. So this is the method while adding the two quantities or subtracting the two quantities. How to find out the error. Okay. So next question is there in the textbook, page number 27. Next page, example 2.9. Copy the question. I will read the question now. The resistance R is equal to V by I, where V is equal to 100 plus or minus 5 volt and I is equal to 10 plus or minus 0.2 ampere. Find the percentage error in R. That is the question. Find the percentage error in R. Okay. So how will you find out? Here R is equal to V by I. So what is it? R is equal to V by I. Isn't it? R is equal to V by I. It is the quotient. Isn't it? R is equal to V by I. Division. And in division, what is it? If A is equal to A plus or minus delta A and B is equal to B plus or minus delta B, and if Z is equal to A by B, Z is equal to A by B, what is it? The relative error. Isn't it? The relative error will be equal to sum of the relative errors. Delta A by A plus delta B by B. Delta Z by Z is equal to delta A by A plus delta B by B. Isn't it? So that is the quotient. So we can find out here what is V. V is equal to 100 plus or minus 5 volt and I equal to 10 plus or minus 0.2 volt. Isn't it? So here we can compare with this. This is V and this is delta V. So here we can write delta V is equal to 5 and V is equal to 100. Then I is equal to 10 and delta I is equal to 0.2. Isn't it? And this is R. Isn't it? So what is the relative error in R? That is delta R by R. Isn't it? Relative error in R is delta R by R. And here the question is percentage error. Find out the percentage error. So it is into 100 is equal to, as per the equation, what is it? Delta A by A. Here Vn. So we can write it as delta V by V into 100 plus delta I by I into 100, because we have to find out the percentage. Okay, so what is it? Delta V by V. Delta V is 5, isn't it? 5 by 100 into 100. 5 by 100 into 100 plus delta I by N, that is 0.2 by 10 into 100. So here 100 get cancelled, 10 get cancelled. So it is 5 plus 0.2 into 10, it is 2. So what is the percentage error? That is 7%. Okay, delta R by R into 100 is 7%. Okay, so you have to remember this always. So we can compare it. So this is the form. A is equal to A plus delta A. B equal to B plus delta B. So here B equal to V plus delta V. This is V and this is delta V. So use the equation. You will get the answer. It is 7%. Okay. So the next question is example 2.10. The same page. That is two resistors of resistances. Two resistors of resistances. R1 is equal to 100 plus or minus 3 ohm and R2 is equal to 200 plus or minus 4 ohm are connected. First one in series and B in parallel. Find the equivalent resistance of the A series combination and parallel combination. Okay, and you have to find equivalent resistance. You have to find out. Okay, for the first one, series no problem. We have discussed already that you can do. R is equal to R1 plus R2 is equal to 100 plus or minus 3 plus 200 plus or minus 2. So 100 plus 200, that is 300, and the error will be 3 plus 4, that is equal to 7 ohm. Series it is okay. Then let's go for the equivalent resistance in parallel. Equivalent resistance in parallel is 1 by R, isn't it? Parallel combination, it is 1 by R is equal to 1 by R1 plus 1 by R2. Isn't it? That is the parallel combination equivalent resistance you studied in 10th standard. So we can write it is R2 plus R1 divided by R1 R2 or R equal to, that is the equivalent resistance R is equal to R1 R2 divided by R1 plus R2 reciprocal. Isn't it? So here what is it? R1 is equal to 100 plus or minus 3 ohm and R2 is equal to 200 plus or minus 4 ohm. Isn't it? So here it is, this is delta, this is R1 and this is delta R1, this is R2, this is delta R2. Okay. So this true value we can find out. So substitute the equation, that is 100 into 200 divided by, what is it, 100 plus 200. Isn't it? Is 200 by 3, that is 66.6 comes, isn't it? 7. 66.7 ohm, that is R. Now we have to find out what is delta R. Isn't it? Delta R we have to find out. So how will you find out delta R? Here what is the resultant error? Here what is it? R is equal to R1 R2 divided by R1 plus R2. So here what are operations are there? Multiplication is there, like product of R1 R2, then quotient of this, division is there, and sum of this. So all the three are coming here. All the three combinations which we discussed are coming here. Neither these except this subtraction or this difference, all the operations are coming here. So here first we can go for the product. So the product of, so we can write it as delta R by R. Isn't it? The relative error will be, here first comes product. So in the product what is said? The relative error will be the sum of the relative errors. So R1 by R1 plus delta R2 by R2. Like this is the error in the first section. Then what comes? Division. So there what is it? Again plus. Isn't it? Plus what is it? The division, what is it? The absolute error of this plus the absolute error of this. Isn't it? So what comes here? Here it is. So what is it? It is at R1 delta R1 by R1 plus delta R2 by R2. That is the relative error in the product. Then here comes quotient. So plus relative error of this, isn't it? A plus A equal to A plus or minus delta A. B equal to B plus or minus delta B. Then A by B comes, what is it? Delta Z by Z is equal to delta A by A plus delta B by B, isn't it? Sum of this. So A by B. So this is A and this is B. So what is B? Delta B. What is B here? R1 plus R2. So compare with this. This is A and this is B. A and B. So A is delta and what is A? It is the product of 2 R1 and R2. So that is why we are going for the sum of this. Okay. So delta B by B. What is B? R1 plus R2. Okay. Then we can substitute for this delta R1, everything we know from this. So we can substitute. What is delta R1? It is 3 divided by 100 plus delta R2 is 4 divided by 200 plus what is it? This is delta R1 plus delta R2. So we can write it as delta R1 plus delta R2 divided by R1 plus R2. So I am writing it again, 3 by 100 plus 4 by 200 plus what is delta R1? 3 plus 4 divided by 100 plus 200. Okay, 100 plus 200. So how much it is? 3 by 100. That is 0.03 plus 4 by 200 means 2 by 100. 0.02. Isn't it? Plus 7 by how much? 300. Like 7 by 300. That is 7 by 3. We can write it as 7 by 3 into 100. What is 7 by 3? How many times? 2 times. Like 6. So 2.3. 2.3. So it is equal to 0.03 plus 0.02 plus 0.23. So how much it is? 0.28. Isn't it? 0.28. So what can we write? What is our result in parallel combination? R is equal to how much we got previously? We got it is equal to 66.7, isn't it? 66.7 plus or minus this relative error. That is, the relative error is this. We have to get R. So what is R? Delta R. What is delta R? 0.28 into R. Isn't it? How much R? R is equal to, we got it already. That is 66.7. 0.28 into 66.7. That is our delta R. Here we are getting delta R by R. Delta R by R is 0.28. So in the equation, what is it? R is equal to R plus delta R. So we have to find out delta R. So this into R gives delta R. So 0.28 into 66.7. See here a slight mistake is there. It is 0.021. It is not 0.2. Okay. Correct it. 0.02. 2 division is enough. So that is right. So how much it is? 0.08. 0.08. So 0.08 into 66.7. So that will be equal to 1.8. So that will be equal to 1.8. delta R is equal to 1.8. So how can we write the result? R is equal to 66.7 plus or minus 1.8 ohm. Understood? 66.7 plus or minus 1.8 ohm. This I explained everything in your textbook. Only 2 steps are there. So from that you can identify, you can understand what is explained there. So I explained step by step. Then the next question, same page 2.11. Find the relative error in Z if Z is equal to a raised to 4, b raised to 1 by 3 divided by c d raised to 3 by 2. Isn't it? That is a question. Here the power is coming. So what is it? Z is equal to a raised to 4, b raised to 1 by 3 divided by c d raised to 3 by 2. So what is it? Power we said is equal to a raised to n. Z is equal to a raised to n. What is it? Delta z by z is equal to n into delta a by a. Isn't it? N into delta a by a. So here what is it? Delta z by z. Delta z by z is equal to a raised to 4. So what is that? Here 4 delta a by a into b raised to 1 by 3. And so product comes, what is it? Sum of relative values. So here again 1 by 3 is there. So 1 by 3 delta b by b. Then what is it? Division comes plus, what is error in C? Delta C by C into another plus 3 by 2 delta d by d. Understood? So here all the combinations are coming. Product, quotient, power. Everything is there. So in the case of power, it is 4n into delta A by A. So 4 into delta A by A. And here it is 1 by 3 delta B by B. Then what is this? This is the product. So it is the sum of the relative errors. And here C. So C it is delta C by C. And here 3 by 2 delta D by D. It is product, so sum. And here the quotient, so it is the sum. Okay. So the value comes, you can substitute and find out. Okay. And the last question, that is example 2.12, that you read and try to solve. If it's not getting, I will explain in the next class. Okay. So next, or you can contact me, you call me, I will explain. So next we have to discuss about the significant figures. That is our next topic, significant figures. So what are significant figures? What are significant figures? Suppose you are making a measurement. Okay. You are finding out the time period of a simple pendulum, for example. Okay, time period of a simple pendulum. And how will you measure the time period? With the help of the stop clock. Stopwatch is there, and we will make the oscillation and we can find out the time period. And you are getting the time period as 3 sets of observations we are doing, and we are getting it is 6.2, then 1.62, 1.63, 1.65, like that. Okay, and look at the first one. After looking the result, you can see that this 1.6 is fixed, isn't it? That is no much change in that 1.6. So that value is close to the time period of the simple pendulum. And here 2, 3 and 5 are, it is changing and may change or may not change. Okay. So here in this result, in this length, in this value, not length, in this physical quantity, there are, you can see that 3 digits, isn't it? 3 figures we can see. Then the first 2, that is 1 and 6 are reliable, and that is the we can say it is the actual value. Okay. And the third digit is may change or may not change. That is the condition. So I am saying that in this measurement there are 3 significant figures. There are 3 significant figures. So what are significant figures? In a measurement, the first 2 reliable figures plus one more figure or one more digit comes next to that. So that those figures are known as the significant figures. Here I am adding one more, that is 5 I am adding. But here 5 is not a significant figure. Okay, because 1.6 is a reliable one, we can say that that will be the actual time period. Okay, plus next figure that may vary. Okay, so those 3 digits are known as the significant figures in this. And suppose you are measuring a length 287.6. Length that is 287.6 centimeter. Okay, measuring a length. So in that, if you are taking the proper measurement, every time you have to get it is 287. So that is a certain value. Okay, that is a certain value, and this 0.6, that is the decimal value, may change. That is, it may come 7, 0.7 or 0.5, it may vary. Okay, so in this measurement, we can say that there are 1, 2, 3, 4 significant figures are there. So what is it? First 3 are certain and the last one is one uncertain. Okay, so in all the measurement, we are taking this as the significant figures. Then you are taking a measuring a mass, that is 1000.5. Okay, anything you are measuring, its mass is equal to 1005.2. Okay, and 25 comes. But the 1005 is a constant. Any object you are measuring, its mass is equal to 1005. In all the measurement, you will get that 1005. Then the other one may change, 0.25, isn't it? 0.25 or 0.31, like that it may vary. So what is it? All the certain numbers plus one uncertain. So how many significant figures are here? 1, 2, 3, 4 and 5 significant figures. Understood? So such figures, so in all the measurement, we have to represent the significant figures. We have to know the significant figures, and accordingly we are writing as the, that is after the decimal, we are limiting the numbers according to the significant figures. Okay, so write down the next question. What are significant figures? What are significant figures? Write down the answer. Significant figures are those digits in a measured quantity, which are not reliably, reliably, or about which we have confidence in one measurement, in our measurement, plus one additional digit, that is uncertain. Understood? So first digits are the certain, no change in that. Plus one more digit, and that digit may be uncertain. Okay, it is uncertain. So that are the number of significant figures, and there are some rules. So first you write down the rules. First one, write the question, state the rules for counting the number of significant figures in a measured quantity. measured quantity. Write down first rule. First you write down the rule, then with the help of the example we can discuss that. Okay. First one, all non-zero digits are significant. All non-zero digits are significant. Second one, all zeros between two non-zero digits are significant. All zeros between two non-zero digits are significant. Third one, all zeros to the right of a non-zero digit. All zeros to the right of a non-zero digit, but to the left of an understood decimal points are not significant. Fourth one, all zeros to the right of a non-zero digit. All zeros to the right of a non-zero digit, but to the left of a decimal point. Are significant. Fifth one, all zeros to the right of a decimal point. All zeros to the right of a decimal points are significant. Sixth one, all zeros to the right of a decimal point, but to the left of a non-zero digit are not significant. And the last one, the number of significant figures does not depend on the system of unit. But there are 7 rules are there to identify how many significant figures are there in a measured quantity. So the last one is very important. So here you are following that is CGS system or SI system. So in CGS system we are getting what is that the measurement. Say here it is 287.6 centimeter. Okay, 6 centimeter. So you are converting it into SI system. SI system, what is it? It is in meter. That is 287.6 into. So this is in centimeter. We have to convert it into meter. That is 10 raised to minus 2. Less centimeter to meter. It is 10 raised to minus 2. So how much it will come? It is equal to 2.876. Isn't it? 2.876 meter. So here how many significant figures are there? 4. And here how many significant figures are there? 4. Okay. So whatever be the measuring system, there is no change in the number of significant figures. So next we can discuss all the rules. So this is the last one. Whichever be the system of unit, number of significance will be same. Okay. So what is the first rule? All non-zero digits are significant, isn't it? All non-zero digits are significant. That is 287.6. All these are non-zero digits. And here 12.21. So all the non-zero digits are significant. Here 4 digits are there. Here 4 digits are there. Here what is it? 3 digits are there. See, 3 significant figures are there. all non-zero. So in a number, what is it? You have to go for the non-zero digits, and all the non-zero digits are coming as a significant figures. Okay, then what is the next one? All zeros between two non-zero digits are significant. All zeros between two non-zero. The first example, 1005. So here how many significant figures are there? 1, 2, 3, 4. There are 4 significant figures. How many significant figures are there? 3 significant figures. Okay. So in between non-zero, zeros are coming, non-zero digits, zeros are coming. That 0 is also considered as the significant figures. And third one is all zeros to the right of a non-zero digit, but to the left of an understood decimal point are not significant. Okay, that is all zeros to the right of a non-zero digit. Zeros right of a non-zero digit, and where is it? But to the left of an understood decimal point. Now we are not putting the decimal point, but we know that it is over. So such zeros are not significant. Okay, so here how many significant figures are there? There are only 2 significant figures. Okay, and along with that you add. So here there are 2 significant figures. Okay, there are 2 significant figures. And see here one more speciality is that here we are writing 5600 meter. We are specifying the unit here, 5600 meter. Then here the significant figures are 4. Okay. So after a quantity, we are mentioning with the unit, or we are considering it as a physical quantity or a measured quantity. The zeros will be considered as the significant figures. Here, what is it? It comes right off the non-zero digit. So it won't consider as the significant figure. So here only 2. And here we are writing as the meter, mentioning the unit, specifying the unit. Then there are 4 significant figures. Okay, 4 significant figures. First one is all non-zeros are significant figures. Then zeros between 2 non-zero digits are significant figures. And next one is 0 comes last, that is right of the non-zero digits are non-significant, but if it is mentioned by its unit, it becomes significant. Then what is the next one? Fourth one, all zeros to the right of a non-zero digit, but to the left of a decimal point are significant. But to the left of a decimal point are significant. Here we are not putting this decimal point, and here see 0.1. Okay, 0.1. So now what is happening here? This zeros you have to consider as the significant figures. So here how many significant figures are there? 1, 2, 3, 4, 5. There are 5 significant figures. Okay. Your unit comes or the decimal point comes, you have to consider zeros as the significant figures. Then the next one is all zeros to the right of a decimal point are significant. All zeros right of a decimal point. Right of a decimal point. 56.0. Okay. Right of a decimal point are significant. So how many significant figures are here? 1, 2, 3, 4, 5. There are 5 significant figures. Okay. But here only what zeros are not considering. Okay. Not considering as the significant figures. Here unit is written. So both the zeros are also significant figures. Here the decimal point comes. Then zeros are significant figures. And 0 after decimal, that is also considered as the significant figures. Okay. Then all zeros to the right of a decimal point but to the left of a non-zero digit are not significant. All zeros to the right of a decimal point. All zeros to the right of a decimal point, but left of a non-zero digit. 5600.01. 5600.01. So what is it? All zeros to the right of a decimal point. Right of a decimal point, but left of a non-zero digit. Right of a decimal point, left of a non-zero digit, that are not considered as significant. So here how many significant figures are there? 1, 2, 3, 4, 5. This 0 is not significant. Understood? Then the next one is, sixth one we discussed, and the seventh one we already discussed. The number of significant figures in all the system of units are same. Okay, so what are significant figures? Suppose if you are getting a quantity, so only two cases it's not considered as significant, isn't it? One is last two numbers are coming here, 100. So 100, only one significant figure. If unit is mentioned, there are three significant figures. And after 100, one decimal is put. How many are there? Three significant figures. Isn't it? So you study those rules, then you can do it. You can identify it very easily. Okay, what is significant figures? It's just the number. So certain value plus one uncertain number. Okay, certain figures plus one uncertain figure, that is the significant figures. So write down some questions and do state the number of significant figures in the following. State the number of significant figures in the following. 0.7 meters square. So there are 9 questions. So write down and try to find out the significant figures. Okay, answer I will give you. I will put it in the group. So you try to find out based on all the rules which we discussed. Try to find out the significant figures. And what will be the significant figures by addition, subtraction, division and multiplication. So after addition and subtraction, the significant figures, the number of significant figures in the resultant of the quantity, it will be written as same number of decimal positions. Okay, decimal point. That is here we are adding this 12.24 and 13.37. So in the result also, here after decimal, how many positions are there? 2, isn't it? So in the result also, you have to retain that 2 decimal points. Okay, and in what is it? The product and quotient, that is a multiplication and division, same number of significant figures will be there. So you have to retain the same number of significant figures. Okay, like that you have to write the result. Understood? So that is the significant figures after the mathematical operations. So you copy this and try to do this. So result I will, the answer I will put it in the group. Okay, so study the rules first. Okay, it is very easy. Just you read it, then you will understand what is it. And here power of 10 is there, 10 raised to 24 is there. So you know how many zeros you have to put and decimal points are there. Accordingly you can write. Okay, so that is about the significant figures. Okay. Next we have to discuss what are the rules which we are following while rounding the figures. Okay, while rounding the figures. Suppose you are getting a result that is 2.746. 2.746 is a reading which you are getting and you have to round it off for 3 significant figures. 3 significant figures. So 3 significant figures means 2.7 and 4, isn't it? And this 6 is an insignificant figure that we are dropping. So after rounding, what will be the value? You know that, isn't it? It is equal to 2.75, isn't it? If it is more than 1, 1 will be added to the, it will increase by 1, isn't it? It comes 2.75. Or if it is 2.743, 2.743, what will be the result after rounding? It is 2.74, because if it is more than 5, we will add 1. If it is less than 5, we will leave as such, isn't it? Isn't it? Okay, so that is about the insignificant figures, more than 1 and less than 1. If it is equal to 1, what is it? If it is equal to 5, not 1, 7.45, 2.745, sorry, 2.745. So here we have to round it for 2 significant figures. 5 we have to drop, isn't it? And I'll write one more example. 3.5. In both the cases, the third figure which we want to drop, that the insignificant figure, is 5. And here you see the preceding number, here it is 4 and here it is 3. That is 4 is even and 3 is odd. So in such cases, if you are dropping this 5, here we will get the result as 2.74. That is, we will leave the preceding number as such, and here it is odd, so it is 2.74. That is, 1 will be raised with the second figure after decimal. Okay, so this is the odd number, so raise 1, even leave as such. If the insignificant figures which we want to drop is 5, if it is more than 5, plus 1, less than 5, will be as such. No change in the number, isn't it? That we are studying, you are doing that, isn't it? Decimals, how will you fix the number of decimals? Okay, so these are the 2 rules whether we are following. Okay, so this you keep in your mind, no problem, nothing will come. So while doing, while calculating, you have to follow this in your mind, keep this in your mind, and we have to follow this. Okay, we have to apply this. Understood? Nothing more, just have an idea about this and the significant figures also. Okay, so that's all for today. Complete the notes, question and answer I gave. So write it, and that last problem also you try to do. Okay, that is finding out the significant figures. And anybody feeling any doubt, you can call me, I will explain you personally. Okay, for the significance figures, that's the first thing, is you study those rules. Okay, what are the rules which we are following? Answer I will give you. Okay, so that's all for today. So in the next class, we will discuss the last topic of this chapter, that is dimension. Okay, dimension and dimensional analysis. Okay, thank you.